A 50-meter, 130,000-ton killer asteroid traveling at 50,000 kilometers an hour totally annihilates a major city. A solar blast knocks out power grids and kills off more than half of our vital satellite networks. A runaway cascade of space junk careens out of control and creates a deadly blanket of space debris that is so severe we lose viable future access to space for decades to come. You might think that these are just science fiction fantasies, but no, they are very real space threats that now threaten our world. These are the cosmic hazards that beset our small 6 sextillion-ton spacecraft that we call Planet Earth as it zooms around the sun at over 100,000 kilometers an hour. As we add more mega cities with populations of over 10 million. As we add more people, perhaps as many as 12 billion by the year 2100, and become more dependent on modern technology and vital infrastructure, our risks grow exponentially. Coping with these cosmic hazards and mounting a defense against them are not trivial speculations by sci-fi writers. What is now called planetary defense is being seriously undertaken by space agencies, observatories, astronauts, scientists, and the United Nations. The need for global action is increasingly urgent as we grow more and more dependent on modern infrastructure, electrical grids, and satellites. We become more and more vulnerable. Understanding cosmic threats and finding better ways to protect our critical modern infrastructure is now imperative. Let's consider the 3 major threats we face today. The first step in coping with asteroid and comet threats is learning more about what are called, by astrophysicists, near-Earth objects, asteroids and comets that could hit Earth. The good news is that NASA and other space agencies have used space infrared telescopes, as well as ground observatories, to find about 90% of potentially hazardous asteroids, at least those that are more than 1 kilometer in size, of which there are over 1,000. A worldwide team of observers report their findings from all over the world to the Minor Planet Center at the Smithsonian Observatory in Cambridge, Massachusetts, and the Safeguard Foundation in Italy. A new United Nations International Asteroid Warning Network now aids in this work.
Asteroid impacts are tremendous events, and once you have a good, solid orbit on them, you can predict 100 years ahead of time whether there is a likelihood of an impact with the Earth.
That's the good news. The bad news is that the city-killer asteroids can be as small as 35 meters in size if traveling fast enough. It is estimated that there are perhaps 1 million of these smaller but lethal near-Earth objects, and most are yet to be identified. NASA observers are working on mapping the orbits of near-Earth space rocks more than 140 meters in size, as instructed by the United States Congress. But we now know that this process will not find the million city killers that are smaller than the current search window. Any one of these potentially hazardous asteroids possess the kinetic power of a thermonuclear bomb.
If they hit Earth, bad things can happen. And so, for example, the asteroid that hit in Tunguska in 1908 was about 40 meters across. Okay, and that caused an area of devastation roughly the size of the San Francisco Bay Area.
If it were to splash into the Atlantic Ocean at just the right spot, it could destroy all coastal cities, from New York to Washington, D.C. So what are we doing about it?
There's a million or so objects whose orbits cross Earth's orbit. And we currently know of about 10,000 of them. Our project, called Sentinel, is to launch a telescope, a space telescope, to catalog and track and make this map of all the asteroids in the inner part of the solar system.
More and more people agree that we need space-based projects like Sentinel and NASA's parallel NEOCAM program to find the much larger population of space rocks that endanger our planet. Just one wayward space rock over 35 meters across, weighing some 100,000 metric tons and traveling at 30 kilometers a second, would make duck soup out of an entire New York, Washington, D.C., Beijing, Cairo, Paris, Mexico City, or Tokyo. Any one of the nearly 50 megacities of 10 million or more people that blanket our planet are at risk. We can spend hundreds of millions of dollars now about the cost of a freeway interchange to prevent such a catastrophe, or risk the deaths of potentially millions of people and trillions of dollars of damages. We now know that dangerous space rocks are not a once-in-a-million-year type threat. A 130,000-ton, 50-meter asteroid named 2012 DA-14 flew within about 25,000 kilometers of Earth orbit in February 2013. And like Arnold Schwarzenegger, it will be back. This near-miss asteroid has huge mass, the size of several aircraft carriers, and travels at nearly 85 times the speed of sound. This would make a very large and deadly dent in our planet. If it actually hit Earth, it would impact with the force of more than 100 nuclear bombs. Fortunately, we have time. The projected impact is in 2106. This asteroid, if we don't divert it, could have the equivalent impact of a world war. We must start to take this type of cosmic threat seriously. It is not science fiction, but scientific fact. Skeptics may say, close but no cigar. These big space rocks always turn out to be near misses. But the dinosaurs know very well that this is not true. We need to learn from their misfortune. Unfortunately, there are more immediate cosmic hazards than potentially hazardous asteroids and comets, and they pose an even greater risk factors than giant space rocks in terms of likelihood of impact on our daily lives within the next decade. Solar flares and coronal mass ejections from the sun are a constant threat. The Carrington event, which was the largest coronal mass ejection about which we have exact data, occurred a century and a half ago. But the threat is always current, especially during what is called solar max. The Montreal event of 1989 zapped transformers across northeastern North America, leaving millions without power from Illinois to Quebec. The so-called Halloween event brought sustained massive solar flares and explosive solar winds, blasting Sweden for 2 weeks and peaking in late October 2003. Today, we face significant threats from two types of closely related but different types of solar storms. The first are solar flares, which provide a surge of radiation. These flares travel at the speed of light and reach Earth in just 8 minutes' time. The second type of even more deadly solar storm are called coronal mass ejections. These ejections are caused by colossal solar magnetic events that come from the sun's corona. Solar flares and their accompanying radiation won't just leave you with annoying sunburns. They bring the very real danger of genetic mutation. Frogs in Arctic regions, where the radiation hits the hardest, have shown signs of such mutations. There is also certainly the elevated risk of skin cancer, especially where the ozone holes exist around the poles. Residents of Adelaide and Melbourne, along the Australian southern coast, and New Zealand have 40% higher incidence of skin cancer than the general population. These massive solar storms are much more likely to occur than an asteroid strike. In fact, NASA has calculated that the likelihood of a major solar strike within the next decade could be as high as 12%. Lloyd's of London did an economic assessment of the impact that a solar strike like the Carrington event could have if it hit the world today. This calculation of cumulative damage came to a staggering $2.6 trillion. That would equate to 40 times the damage caused by Hurricane Sandy, or 25 times the damage of Hurricane Katrina. And this is just the financial damage. The death toll due to disease and starvation would undoubtedly be catastrophic. Since we are some 150 million kilometers away from the Sun and only about 12,500 kilometers in diameter, we are a fairly small target. So fortunately, a large majority of coronal mass ejections miss us and go zooming harmlessly out into space. Most ejections originate from active regions on the Sun's surface, amid groupings of sunspots associated with frequent flares. Magnetic loops snap underneath the Sun's corona and release these massive floods of ions into space. While we are starting to understand their causes, we still do not know enough to predict when these events will occur or how powerful they will be when they do. A major solar weather event could have a widespread negative impact around the world on many important human activities and commercial systems. And what do we know about how the Earth's magnetosphere serviced to protect us from massive solar storm? The answer is unfortunately much too little.
The sun storms are not really getting worse, but Earth's magnetic protection seems to be weakening, and we certainly keep adding infrastructure in space and on the ground that can be knocked out. The European Space Agency Swarm satellite has shown us that the magnetosphere over the Western Hemisphere is weakening. One likely reason is that the Earth's magnetic poles are getting ready to flip. In fact, the data suggests the magnetic North Pole has already moved all the way down to Siberia. With more satellites up there, more computer networks and electrical grids to be zonked, we're definitely more vulnerable than ever.
So how can we make sure that we are warned when a massive coronal mass ejection is on the way? What can we do to protect our satellites and the electrical grid? In February of 2015, NASA launched the Discover satellite that will monitor both the Earth's atmosphere and the Sun from a special point in space called the L1 Lagrange point. It is the latest monitor in the sky that will be our celestial lighthouse to warn us of dangerous sunspot activity and solar eruptions. And what if a major solar storm hit Earth? Because the protective magnetic field around the world seems to be weakening, the impact of a solar blast could be substantially worse than that sustained by the Carrington event of 1859 we heard about earlier. What could occur if a massive solar storm containing billions of ions blasted our planet, knocking out most of our satellites and zapping our power grids? Consider a day without satellites. In Paris, many people noticed the loss of TV satellite news and international sporting events. In London, the GPS satellites that assist aircraft landing, even through dense clouds, fail, meant all flights had to be diverted. In Washington, D.C., the failure of secure satellite communication systems at the Pentagon leaves soldiers, ships, and aircraft cut off from their command centers. In this, a nuclear attack? No one knows. Chinese fishermen near Hong Kong find their satellite phones no longer work. Well offshore in the Chinese Sea, they are completely cut off from the mainland. In rural India, where most banking is accomplished by satellite communicating ATM machines, farming villagers can no longer access their money. In Rio de Janeiro, electronic funds transfer systems have shut down. Banking systems around the world start to fail. In Mexico City, access to the internet has been completely lost. In fact, around the world, internet has become inaccessible. This is because it's synchronized by signals from global positioning satellites. Once GPS goes down, the World Wide Web goes down only a few hours afterwards. The full economic, educational, healthcare, transportation, and vital infrastructure impacts are now being realized. Billions are affected as the shutdown inhibits weather forecasting, government, and defense communication. as well as disaster recovery. The day without satellites and power due to the massive solar storm has overwhelmed the world. For the rest of the week, power grids are gradually brought back online. Satellite navigation and communication systems are recovered, and new replacement satellites are launched. Replacement transformers are rapidly installed. Traffic signals, water, and sewage systems are brought back online. Internet service is slowly restored, and transportation systems begin running again. Warfare and major crime waves have been averted. Things may be getting back to normal, but had the massive solar explosion of ions been worse, recovery might have taken months rather than days, bringing humanity to its knees. The global economy might have shut down for months. The human and financial losses, devastating. People depending on transport for food could have starved. Our world as we know it, destroyed.
Called the Kessler syndrome, and he back in the 60s and 70s said if we don't take care and stop using explosive bolts and leaving fuel in rockets that can explode, over time this debris is going to build up, and at a certain point it will reach where it will just cascade and create more and more debris and basically go out of control and deny us access to space.
Swarms of debris in low Earth and polar orbits now threaten weather and communication satellite constellations, as well as the International Space Station, the Hubble telescope, and even the new James Webb telescope that promises to let us see back to the beginning of time.
What's called the Kessler syndrome is really nothing more than the way nature operates, with orbits that cross one another. And they'll eventually collide with one another. They'll create smaller debris and a certain amount of larger debris. And then that larger debris can go on and cascade to create even more debris, and you can get a runaway cascading effect. When that's applied to low Earth orbit, that phenomena is taking place right now, but at a very slow rate. At about once every 10 years, we're seeing a collision between large objects, and then but that rate will increase even if we don't add any new objects to Earth orbit.
Orbital debris poses a risk to continued reliable space operations and to the safety of persons and property in space and on Earth. We need to minimize the creation of orbital debris by government and non-government operations in space in order to preserve the space environment for future generations.
The U.S. Congress is working on a Critical Infrastructure Protection Act to improve efforts to assess and protect ourselves from cosmic hazards.
If we actually found a threatening object, we have a process that's been put in place to actually start working that. For example, the United Nations has set up a committee. It's called the Space Mission Planning Advisory Group, which is intended to bring together the space agencies, worldwide space agencies, where they can start thinking about how they would actually handle a threat like that.
The United Kingdom is putting in place ways to back up GPS satellites as a mean to maintain a synchronization of the internet. Green energy systems that produce power off the grid are being designed to back up our electrical energy systems in case they get fried by a solar storm. The UN General Assembly in December 2013 established an international asteroid warning network to coordinate a global defense against incoming asteroids and comets. In his 1973 science fiction book, Rendezvous with Rama, Arthur C. Clarke envisioned that Earth would set up a planetary defense system called Safeguard, designed to prevent near-Earth object impacts. This was set in 2077. For once, humans are ahead of the game. But if we are to cope effectively with cosmic mega disasters, we need to do more to identify these real threats. We also need to find new and innovative strategies to cope with them. We have more and more cities and billions more people living in them, dependent on sophisticated infrastructures. information and electronic networks, and key satellite systems. Our vulnerabilities are increasing every day. Planetary defense is more than a good idea. It is a must-do program for all spacefaring nations.